Welcome to this video. In this video, we'll have a look at one of the most important and trending databases you can work with as a web developer these days, MongoDB. We'll have a look at what it exactly is, how it works, how we can use it, and what belongs to its rich ecosystem, because that's so much more than that little database you can install locally on your system. So we'll have a look at all these things, and after this video, you'll already be ready to start using it in your next applications. So let's start. So what is MongoDB? Well, first let's start with the name. It comes from the English word humongous, which basically means that it can store lots and lots of data, and that is why that name was chosen. So humongous basically means that there is a plenty of it. Now, in Germany, that's actually a bit of a strange name, but just as a side note, maybe you can find out why, but this is where the name comes from. The core idea behind MongoDB is that we can store a lot of data in there and work with it in a very performant way so that we can write with high throughput and retrieve data very efficiently and fast. I'm talking about milliseconds here, which is of course super important for modern web and mobile applications where you typically use MongoDB because you can deliver data to your users fast. Now, I also got a video, by the way, where I compare NoSQL databases, as MongoDB is, as you will learn, and SQL alternatives like MySQL. So definitely check out that video and article to learn more about when to choose which. In this video, I'll obviously focus just on MongoDB. So how does it work then? Well, it's a database, and therefore it's all about, well, storing data. We might have a shop database. So in our MongoDB database server, which we start in the end, you will learn how to install it and how to bring up such a server in this video. On that server, you can have multiple databases. And let's say we have a shop database because we're building an online shop. Now, in that database, we then have something called collections. We might have a users and orders collection. If you're coming from a SQL world, collections would be tables. So collections are basically the parts of our database where we put our data into. Now, the data itself would be a row or entry in a SQL database. In MongoDB world, we're talking about documents, which look something like this. If you're working with JavaScript, then you might recognize these curly braces. That looks a lot like JavaScript objects, and indeed, MongoDB uses a notation or a data format which they call BSON, very similar to JSON, I'll come back to that in a second, which looks a lot like JSON and actually also works a lot like it. So we store such documents in there. And one important thing and one key difference to SQL databases is that these documents are schema-less, which means, as you can see here, we can have one collection, one table, if you want to call it like that, where we store different data in. Here we have one document which describes a user who has a name and an age, and the other user only has a name because maybe we didn't retrieve the age data. In MongoDB, it's no problem to store such mixed data in one and the same collection, which makes MongoDB very, very flexible. And it's especially great, for example, for growing businesses where you don't know which kind of data you will need in the end or you will be able to gather in like 6 months. But you want to start now, and you can basically store the data you have. And if you collect more data in 6 months, you can add it to the same collection. Obviously, you'll have to work on your querying logic then and make sure you don't rely on data which might not be there for all documents. But in general, this is a great advantage, or it can be a great advantage at least. Now, I was referring to that data format, which is called BSON, which basically stands for binary JSON. Now, JSON is a data format you know from JavaScript or from web development in general. It's a data format that looks pretty much like what you see here, like a JavaScript object in the end, you could say. Now, BSON, binary JSON, is in the end using the same format, but it's binary encoded to make working with it behind the scenes on the server more efficient, to make it work with basically all languages you might use to reach out or to connect to your Mongo database. So it gives you more flexibility, but you don't have to worry about that. You, in the end, store objects in your database that look like that. And you will see how we create them in just a minute. Now, the cool thing we can see here is we're really flexible regarding the data format, and I said that you can mix data structures in the same collection. You can also have so-called embedded documents. So here we have one document, right, with name, age, and address, but the address is a so-called embedded document. So it's a document in a document, and that allows us to keep data where we need it. And that's another important difference to SQL databases. There we split data across tables. We might have a users table and then an address table, and we would match them with the ID. But here, the idea is that we put data that belongs together into one document. Now, there are different strategies for distributing data too, but generally, you want to keep data together because that makes retrieving it and working with it much easier because you already got everything you need without complicated joins, which cost performance. Or which can cost performance at least. So here we got all we need and we can just retrieve it and we don't need to join multiple collections or tables. You can also have multiple nested documents, like for the hobbies here, which is an array of nested documents. So this is all possible, this is really flexible, and working with it is a lot of fun because especially if you're coming from a JavaScript world, but you can work with MongoDB just fine from PHP, Python, and so on too. But if you're coming from a JavaScript world, this is all syntax or code you already know, and therefore working with it is really, really simple and fast. Not the worst combination. Now, one important note, of course, has to be made about relations. Since we generally keep our data in one place, we don't really have relations across multiple collections, though we can have them. But if we have them, we basically have to merge them manually. We basically have to write queries where we retrieve the first documents and then reach out to another collection and find the fitting connected documents on our own. But often you don't have that split up approach. But you can do that too in MongoDB. Now that's enough of the theory for now. Time to get our hands dirty. So let's visit mongodb.com and see how we can get started using it. On mongodb.com, we can see that we can get started for free, which is not the worst. And if we click that button here, we're taken to a page where we actually get suggested to use MongoDB Atlas. Now, I will actually use that in that video. MongoDB Atlas is a cloud-managed Mongo database. So a database running in the cloud to which we still can connect from our local machine or from any app we're writing. Now, you don't have to use that cloud solution though. You can also install it locally. In the top right, if you click on Get MongoDB, then you also start with the Atlas selected, but you can switch to the community server, which is the freely available server you can install locally on your machine. Here you just have to choose your operating system and then download and install it, and make sure to follow these installation instructions in case you're facing any errors or in case you just want to, well, make sure that you get it right. Now, there's nothing wrong with installing that locally, and it might be the first intuition you have. But actually, the Atlas server gives you, in my opinion, first of all, an easier way of starting because it's really simple. It's also free to get started with that. That's also important to mention. And it's also more realistic because once you finished working on your, let's say, Node.js app or whatever it is where you connect to MongoDB, once you've finished with that, you will need some kind of deployed Mongo database. And deploying a Mongo database, just like any database, is a more complicated process because obviously you want to have a scalable, performant, secure database. And MongoDB Atlas does all of that for you. It's easy to set up sharding there, which basically is the process of using multiple servers that are connected together to store and retrieve and work with your data. You also get replica sets there, which basically means that your data is replicated across multiple nodes for fault tolerancy, so that when one node fails or is under heavy pressure, you can get the data from another node. You also can retrieve it faster, therefore, because you can work with multiple nodes with the same data simultaneously. So all these things come for free with such a setup. You have to manage them on your own when working with the community server. The enterprise server, by the way, is basically the same, but with a commercial license. So if you want to have a self-managed server and you want to earn money with it, that would be the option to go. Or there too, you can use Atlas. So I will use Atlas because it's easier to get started and does a lot of heavy lifting for us. You just need to sign up there, but you don't even need a credit card, and it will be for free. And once you did sign up, which I already did, you either end up in the set up your first cluster wizard already, or on a screen like this, where in the end you can build a new cluster. Now here, you basically set up your Cloud Mongo database. And we can use the standard settings here, because these are the settings which will give us a free MongoDB cluster and database. Now, you can obviously also switch to more advanced settings if you need that for production. You can split your database across multiple regions worldwide to have the fastest retrieval time and latency for the different regions your users might be in. You can choose from different cloud providers because it's cloud hosted and not on MongoDB's own servers, but instead they're using these cloud providers. There you can use the region or choose the region where your Mongo database will be hosted in, and I will leave the default. Make sure to choose an option with free tier available to, well, get this for free. Then you have to choose the cluster tier. And here we only got one free cluster tier, which is this very simple one, which is fine for development and testing purposes though. But of course you can also ramp this up to get better, faster clusters with more storage space where you can store more data and retrieve it faster. And you see the prices here, but I'll go with the free alternative. And then you have some additional settings down there, like the MongoDB version. Now, on the free cluster, we are stuck to this version here. Now, that will eventually also change in the future, but right now it's 3.6. On paid clusters, you can actually then also choose the latest version, for example. But for our purposes here, switch back to the free cluster, I'm fine with that version, which is the second most recent. Now, on better or more expensive options here, tiers up there, we could also add backup and shard our clusters, which is that process of using multiple connected servers. And that's not to be mistaken with the replica sets, where we have fault tolerancy. Sharding basically means that we get even more power because we basically duplicate the number of servers that are working together. We don't just have multiple data storage nodes, but we really have the power times 2 or 3 or how many shards we add. So we could do that if we have that tier or higher, and so on. So you can see what you can add. We need none of that, and therefore we can just give that a name. You can go with the default or choose your own, and then click Create Cluster. Confirm that we're not a robot, and then let this spin up. And now this will take a little while, and in the meantime, as it also suggests here, we can go to Security, because we want to secure our cluster here. And that basically means we want to control who can access it. Obviously, we want to lock that down. Only our application should be able to access that because, well, we're probably storing some sensible data in there. Now, what can we do here? You can create different users with different permissions here. Give them a username and a password. You can then choose what they can do. Can they only read, write, or administrate everything? I already got a couple of users there, as you can see. You can add an IP whitelist, and there you can basically control which IPs are able to connect to that cluster. Now I got a couple of IPs there that might be or probably is empty for you. And then you can just add an IP address and enter your current IP address of the local machine you're connecting to this so that you can, well, work with that. And you can also simply click Add Current IP to automatically retrieve that, or allow access from anywhere, which you don't really want to use in production. So we can confirm that, add that IP address, and we can ignore the other settings here for now. So this now gives us a setting where only our local machine, only we can connect to this cluster, and only with one of the users we created here. And if you forgot your password, you can always edit this and even auto-generate a secure one automatically. Make sure to, well, remember your password. You will need it for connecting to that cluster, of course. Now, with that, let's go back to overview and let's wait for this to finish before we then finally connect to this cluster and start writing some queries so that you can not only see how to get it all started, but how it actually works. So now my cluster creation finished, and now it's time to actually connect. Now, if you click on Connect here, You actually got to get a little introduction on how that works, and most importantly, you have to choose a connection method. Now, what does that mean? Typically, you of course use MongoDB from your application you're creating, and that could be an application written with Node.js, with PHP, ASP.NET, Python, whatever it is. Not directly from Angular or React or so on, because you will need a server-side application connecting to MongoDB for both technical and security issues, because you don't want to expose your credentials in your client-side code, which would be the case in Angular or React. Therefore, we either have such an application. If you click on Connect to Application, you actually can choose which language you used, and these are not all languages which are supported. You can click on View All MongoDB driver connection examples to get the complete list. And if you click on that, on Node for example, you get forwarded to a page where you find instructions on how to install and use the Node.js MongoDB driver. So here you would have to basically choose your version to get detailed instructions. You then find out how to connect in Node.js with the MongoDB driver. And obviously you need to install that driver too, but I'll have a look at this in a separate video. They're basically, for Node, is a NPM package, an official one, which you add to your project, and you're good to go. And you can basically start importing the MongoDB package here and access the client. So that is how you would connect in that way. But I actually want to connect differently, so I'll bring this up again. I will use the Mongo shell, and that is basically a JavaScript-based program which you run in your terminal or command prompt on your machine, where you can write all these query commands and connect to your server, be that a local server or that cloud-based server here, and therefore you can play around with it in a very, very simple way without creating a whole Node application just to play around with it. We also got MongoDB Compass, and we'll have a look at this in a while. This is basically a tool which gives us a visual interface, which is great, but we want to use the console because there we write the queries pretty much as we'll also write them in our apps, in our Node or PHP or whatever it is apps we would connect to MongoDB. So therefore, we'll have a look at Compass later with the graphical UI. For now, let's simply use the setup where we write the code which is close to the code you would use in a real application. Here you have to choose your operating system and then download the shell first of all. So this will now download it to my system, and installing it is very simple. You can view the detailed instructions here to then also find out how to connect. For that, you just have to choose the version, and if you just downloaded it, you'll use shell version 3.6 or later. Keep that open. Let's now install that shell. And the installation will differ from operating system to operating system. In the video description, you also find a link with some information on how that works. In the end, on Mac, you just extract a file, and then you get a folder which contains the shell. And you can move that folder anywhere you want and simply navigate into that folder in your terminal and start it. And you start it with this command actually to connect to this cluster for that given user here. And on Windows, it's very similar, by the way. So I navigated into that bin folder that was extracted on Mac. On Windows, you'll have an installer, and once you walk through that, you'll also have a folder where the shell is installed. And then you execute that Mongo command which is in there. You can just copy and paste in the command you got in that modal on the MongoDB cluster. But there is something you have to add on Mac. You have to add // at the beginning. Now this will try to connect to your cluster and ask you for your password. That password is something you set up for the user. If you forgot it, you can of course assign a new one. And then enter that password here, and it should now connect to your cluster. Now once this is finished, you should be connected to the cluster and therefore to the database server, not to a single database. Now you can start running MongoDB commands, and of course you find all available commands in the official docs. One useful one is show DBs. It shows you all the databases you have on your cluster, and if it's brand new, you'll have these two. Now on MongoDB, which is pretty convenient, you don't have to create databases with complex commands. Instead, they are created on the fly when you need them. You can switch to a database with the use command. For example, we can use first test here. Now we switch to the first test database, even though that didn't exist up there. If we now type show DBs, we also still see it because it's empty. But since we switch to first test here, we can actually now use it with the db command, and we can chain commands to that. And now we are on that collection level, right? We're in the database. If you remember that slide from earlier, we now work with collections which then hold documents. Now let's say we want to manage a couple of users. We can simply add such a collection also on the fly. There is no special create collection command with db.users. If you worked with JavaScript, or actually with most programming languages, you know that dot notation from objects. And it's pretty similar here in MongoDB, which is why it's really fun to use it as a developer. A lot of the way you work with that database resembles the way you write code. So now I'm accessing the users collection, which does not exist yet, in the first test database, which also doesn't exist yet. And now I want to enter a user. And that is the part where then both the database and the collection will be created once I really start storing data. Now to store data, I can run insert, and now we have insert many or insert one. By the way, you have auto-completion with tab. Insert one, as the name suggests, inserts one element into that collection in that database. And now that element is like a JSON object. We use curly braces here to define that object. Now, unlike in JSON, you now don't need to wrap your keys in double quotation marks. You can instead just write name, colon, and then the value. So name is the key of that entry you're adding to the database. And now the value here is max. Now, these single quotation marks are only needed because max should be a string. You're not limited to strings, of course. You can store booleans, numbers, you can even store files in there, though that is typically not what you want to do. You rather want to store files on a file system and store the path to the files in the databases, but that's just a side note. And let's also add another field, therefore, separated by a comma, my age. If I now hit enter, this created that object, and it automatically assigned an ID, which you can see here. It's of another type, a so-called object ID type, but in the end, this is the ID which was stored. Now, it would be nice to also see that entry. First of all, let's again type show DBs, and now you see that first test database, which was added because we now have a collection in there. You can also see that if you type show collections. Now here you see that users collection, which we created on the fly. And in that collection, if you want to see all, you can just access db.users, which is the collection, and then find. If you execute it like this, it finds all the documents in there, and therefore right now we only see one, and that is that one document we created with our name and our age. Here you now see these double quotation marks around the keys too, and also that automatically generated ID. So this is how we can add and find documents. Now, often we, of course, want to find just a subset of all the documents. Now, for that, let's first of all add more. Let's first of all clear the console so that it's easier to read with the cls command. We're still in the database. We're still connected. I just emptied the screen. And now let's simply add more. And for that, I'll insert many users. Now, insert many simply takes as many entries as we want. So we can add a user here. Let's say name, man, UL, age, or let's leave out the age here to show that versatility. Let's add another document here, an arbitrary person, which I don't know, Chris, age could be 25. And let's hit enter, and now I get an error here. The reason for that is that this insert many command here actually doesn't take all the documents separated by a comma like this. Instead, we have to pass an array here, so squared brackets. Let's add them here around our documents we want to add. And now this succeeded. And now if I type db users find, we see all three entries. We see that manual is missing an age and still was added without issues to that collection. Now let's say we want to add one more user, db users, insert one, and that user here will have a name, which is Lisa, and the age is 26. So now we have, if we type db users find, we have these four entries or these 4 documents in there. Now let's say we want to find all the users with an age greater than 25, so that Chris is actually not included. Well, for that, we can access it again and write find again, but now don't hit enter. Find, as pretty much all these query commands you can execute, takes optional arguments. And here we can pass a so-called filter. We again pass curly braces, but now we're not defining which element to enter, but our filter criteria. We could, for example, type age 26 to find all entries where the age is 26. And therefore, we only find Lisa because she's the only person in, or the only document in that collection with an age of 26. But I wanted to find all persons with an age greater than 25. And for that, we can use a so-called query criteria. I add another set of curly braces as a value for the age here. And in there are a couple of reserved operations or helpers we can use. And you can find them all in the official docs. These all start with a $, and then there is the GT, the greater than helper. And now I can define the value, which is the value I want to have, or I want to find records which have a greater than value. So if I enter 25 here, now I find Lisa and Max, but not Chris, because 25 is not greater than 25, obviously. And this shows you how easy and fun it is to work with MongoDB and write more complex queries. It's not super complex, to be honest, but it is a good start. Now let's add some nested record. For that, I'm clearing the window again. I'll again reach out to my users and insert one user. And that one user will have a name, let's say Susanna. We'll have an age, let's say 30, and we'll have an address, which then simply is another document created with curly braces here. And that will have a street, first street, and then let's say a city. Let's say that is New Orleans. I don't know if that exists, that address, by the way. Let's hit enter. And if we now find all users again, we see Susanna there with the nested address. Now we can also run queries on such embedded documents. For that, we can again find, and now let's find all users where the address street is first street. We only have one such record. We only have one record with an address anyways, but still, I just want to show you how that works. For that, we again add curly braces to define our search criteria, our filter here. And now in there, we need to use double quotation marks, and then address, which is the field in the document, in the user document itself, which then holds the nested document as a value. And then we use dot notation in here, which is why we need the double quotation marks, and then the nested field, so the street. And then again, just the value, like first street here. If we now hit enter, we find that one entry that matches this. And if I type something else, like here, have an error in the street, we don't find anything, of course. So this is how we can insert and find our documents. Now, obviously, a common task also is to update or delete them. Now let's start with updating. For that, we have another command, the update command. And for that command here, we basically need 2 arguments. The first one identifies which document to update. The second one defines how to update it. And then there's a third one where you can also configure the update mechanism. For example, define what should happen if no document is found. Should it create one or do nothing? Or if multiple documents are found for your filter, should it update them all or just the first one? But we'll focus on the first 2 arguments only. The first one identifies which document to update. And let's say we want to update the user Max. So we want to update the document where name is equal to Max. And then the second value here for the update command is how do we want to update it. And now there's one important thing. We can update in 2 different ways. The first one is that we use curly braces and then $set, and then we define in another set of curly braces which field to change in which way. For example, if I change age to 30 here, and then I do db users find, we see that for Max the age was changed to 30, but please note that the name was kept. If I repeat that command without $set, so if my whole second argument is just age 30, then you will notice that it still updates, but if I find all users, the name is gone. Please note that the ID was not changed. The two IDs here are equal, but the name is gone. So the update method actually differs. If we use $set, we do a patch update, which means we only change the fields we defined to set. If we don't use $set, but we just pass a new object as a value, this new object will replace the old one, but will keep that old ID. So it's still the same document, but all the values have been replaced, and values which were included previously but are gone now will simply be dropped. So this is the update command. And finally, if we want to delete something, well, then we can use db users delete, and then there's delete many or delete one. Now, delete one is straightforward. You again have to search for what you want to delete, and that works in the same way as it does in update and as it does in find. By the way, there also would have been find one and so on if you just want to find one element instead of all matching. But that's just a side note. Let's go back to delete one. So let's say we want to delete the user with the name Chris. If I hit enter here, you see it deleted one, so this seemed to work. And if we now find, indeed, we only have 4 records instead of 5, and Chris is gone. Now, of course, there are other commands and there are a lot of ways of using all these commands. And I strongly recommend diving into the official docs and just play around with them. As you see, it's really easy to play around and you can't break anything. It's just a sandbox database we're using here anyways. So this is how we can play around with it in the console. But of course, sometimes it's also nice to have a graphical user interface. And we can get that too with MongoDB Compass. For that, let's connect again, and let's choose Connect with MongoDB Compass. Choose your operating system and download it, because this is a tool you install locally. Now, as you can see, it's quite big because it's a, full program with a graphical user interface and a lot of logic attached to it. So let's wait for this to finish, and then simply walk through the installer, and we'll be able to then reach out to our cluster and inspect it with that interface in just a second. So once you installed it, and there should be a straightforward installation process for your given operating system, you can connect to it. Now, you'll probably use the latest version if you just installed it, so you can copy that URL to connect to your database. So let's copy here. You'll need your password here, as it of course says. And if you copied that string from the previous page, it actually should ask automatically if it should use that. Though I also need to agree on the license agreements. Yes, this is how it works. Thanks very much. And it should now have populated that with some basic information. If not, you can basically add it manually. Now in here, choose your username, the password, which you have set up on the MongoDB cluster. Leave that authentication database here, because that is the authentication database you have created the user on typically. Now, if that fails, also try creating a new user and make it an Atlas admin. And with that added, you should be able to connect. Now, once you're connected, you see all the databases running on this cluster, and therefore we also see the first test database. And if you click on that, you see all the collections, also here on the left. And if you click on a connection, you of course also see all the documents. So here are the documents we added with the nested data. And if we want to insert a document here, we can do that too. So we can also now edit all the data in here. We can also create new collections in here. As you can see, we could add our products collection. And that allows us to work with this in a nice and easy way, though it is super important to know all these commands you saw in the terminal, in the shell, because these are the commands you will also write in your applications, which you then connect to MongoDB. So that is MongoDB in a nutshell, how we work with it, how we manipulate data, and how it thinks and works. And in my opinion, it's really easy to work with it. As a developer, it's so close to how you write code. In my opinion, much easier to work with it than with SQL databases, though of course that's just my opinion. Now, MongoDB is actually more than just the database though. Or even for the database, there's more than one option. And that is what I want to conclude this video with. If we are on MongoDB.com, we just got started or downloaded MongoDB. But if you click on Solutions, you actually see they got a couple of other products too. Now, what's that all about? MongoDB Enterprise Advanced and for OEM are basically also just the database servers for you to install on your own servers and to work with them. So not the cloud managed version, just the commercial self-managed database. And Ops Manager and Cloud Manager are connected to that because these are tools which allow you to manage your database, manage your own shards, configure it, secure it, all that stuff you have to do if you're running your own databases, and which then is made a bit easier. But still, database administration is something we developers probably won't do because it is easy to mess up and something you probably should get right. That is why we have MongoDB Atlas, which makes that a lot easier and which, for example, allows you, if you get a great app idea, to focus on your code and don't worry so much about the database. Now, we also got other options here though. We saw Compass, that is our graphical UI, but what is Stitch? MongoDB Stitch is a pretty cool offering by MongoDB, which is only loosely connected to their database. Stitch is, you could say, their serverless services offering. Now, if that's not telling you anything, serverless basically does not mean that there are no servers involved. Instead, these are services which are all around. You don't need to manage any servers, not only database servers, but also application servers. You can focus on your code. To be more concrete, Stitch gives you a couple of features which allows you, for example, to query the database from anywhere, including Angular or React apps. And it does so by, in the end, giving you some hidden API, which you normally have to write on your own with Node, with PHP, whatever it is. It gives you that and simply exposes you some functionalities you can execute safely in your client-side code where people are not able to get your credentials and start working with your database all of a sudden. Instead, in the end, you get an invisible API, you could say. Stitch Functions is a serverless offering which is completely decoupled from the database. Here, this is basically something like AWS Lambda or Firebase Cloud Functions. So it's code in the cloud. You write some code, which you then just upload there, and which you can execute, which you can trigger, and which does something that can interact with the Mongo database, but doesn't have to necessarily. Stitch Triggers then works great together with Stitch Functions because Stitch Triggers allows you to run your functions in response to certain database events. Let's say you have a database where you manage user signups. When a user signs up, you maybe want to send an email to that user. And you could use Stitch Triggers to listen to changes to your user database, and whenever, or to your user collection, let's say, and whenever a new document is added, so whenever a user signed up, you send an email to the email address which probably is stored in that document. And you do so by using a Stitch trigger, which runs a Stitch function, which then in turn does send that email through some third-party service. Stitch Mobile Sync is something which is coming soon and which is related to another solution, MongoDB Mobile. MongoDB Mobile is MongoDB running on a mobile device. And the idea behind that, of course, is that connectivity always is kind of an issue on mobile devices. Maybe your users don't have an internet connection. Maybe they only have a slow one. Well, if you have the database on the device, then your users can interact with your app to some extent, even without an internet connection. They can, for example, create new posts and you store them locally, and then once the connection is back up, you sync them to the cloud. And MongoDB Stitch Sync is a service that makes that syncing process fully automated and easier, which will be available soon. So that allows you to write apps that work great on mobile devices or anywhere, and where you can sync your data around and therefore hopefully provide a great user experience. MongoDB Charts is another offering where you can easily connect charts to your database. So you have a web interface where you can create donut or pie charts or line charts, bar charts on your Mongo database data without you writing any code. And you also got some connectors which allow you to connect other business intelligence tools like Tableau to your MongoDB data. So that is the rich suite of things MongoDB offers. The database is their core offering, and almost all other services are connected to it in some way. But in general, MongoDB also is a bit of a broader platform offering, or with the goal of offering you everything you need to build modern web or mobile or desktop applications with a strong and very fast and fun to work with database, as you saw, and a couple of other things that hopefully make your life easier. So that's MongoDB in a nutshell. I hope this was helpful, and definitely let me know if you like this, if you want to see more